Hi, so in today's lecture, we're going to finish off chapter 11. So we're going to briefly talk a little bit more about those double replacement reactions, and then I'm going to introduce that fifth type of reaction, which I mentioned before, the combustion reaction. Okay, so first of all, can you name the four types of reactions we've already done? So we have discussed synthesis reactions, decomposition reactions, single replacement reactions, and double replacement or those displacement reactions. Okay? And then the fifth type, which we are going to discuss today, are combustion reactions. So you might want to just pause and see if you can think about what each of these reactions would look like. And then we'll talk about the fourth one. Okay, so I wanted to just mention a little bit more about those double replacement reactions. And we talked about how these are reactions that involve ionic elements. So these are elements that in solution, the compounds dissociate to produce ions. But you may have noticed that usually one of the products precipitates or it forms a solid. Okay, so we've been writing these as molecular equations. And so you notice we haven't been paying too much attention to this, but you may have noticed that they've been indicated as aqueous and solid. So you always have AB aqueous plus CD aqueous. And then the yield as these switch partners is one that's aqueous. So in this case, AD is aqueous. But the CB, when that then joins together, it forms a precipitate, and that's marked as a solid. Okay, so in addition to thinking about it this way, we can also write these showing that they form ions. So really, when we say these are aqueous, right, that means they're dissociated. So if they're an aqueous solution, they're really not together as this compound AB. They're really as ions that are in solution. So we can write them out as the ions. And so what we're going to do is write them out as ions with their charge. So now remember, ionic compounds are always a cation and an anion, or a positive and a negative. So we're going to write A plus aqueous plus B minus aqueous plus C plus aqueous plus D minus aqueous. All right, and then our products are going to be A positive aqueous, D 1 negative aqueous. And then the CB actually is our solid, which forms a compound, okay? And then once we look at these, we can really see that the A and the D are the exact same on both sides of the reaction. So nothing really happened to them during our reaction. So we can call those spectator ions. And you can actually write an equation that deletes those spectator ions. And so in other words, our equation below really just shows that the B anions plus the C cations come together to form that solid CB. Okay, so let's look at a specific example. So we've got 2 potassium iodide aqueous plus lead nitrate aqueous yields 2 potassium nitrate. So notice we have our displacement plus lead iodide. And in this case, the lead iodide is our solid. Okay, so what we're going to do is rewrite all of these aqueous, showing them as ions. Okay, so notice here you have to take into account how many there are. So you've got 2 potassiums plus 2 iodides, all right, plus lead. And now notice the lead, since there were 2 nitrates to balance it out, reverse the crisscross. That means our lead was 2 positive. Our nitrate is 1 negative, but there's 2 of them because of this subscript. Okay, so that's all the reactants. And then on the product side, you have 2 potassium plus 2 nitrate yields lead iodide. And sometimes it's actually easier to see once you have it written out like this. You can easily see if your equation was balanced or not, because notice 2 potassium, 2 potassium, 2 nitrate, 2 nitrate. All right, and then here is our lead iodide. Okay, so the next thing you want to do is we want to cross out our spectator ions. So these are the ions that are present on both sides of the equation. So we can go ahead and cross out our 2 potassium, so exactly the same on both sides, and our 2 nitrate. And so now we're just left with iodide plus lead is going to give you lead iodide. Okay, and so our net ionic equation just shows the ions that actually participate in the reaction to make the solid. So you can always double check yourself. The solid is going to stay the same in all 3 reactions. And then your ions that should be left are the ones that make up this solid. Okay, so hopefully that's not too hard and you can get used to doing it. So here are 3 practice problems. So I want you to write these out, and this is part of your submission for your homework. So see if you can figure out how to write these out as both ionic equations and then net ionic equations for each of these reactions. Okay? All right. And then I just wanted to include this. You may be thinking, well, how did you know one of them is a solid? So you could actually do the reaction and see what solids precipitate out of solution. But here are some rules, and this is from your CK12 book. So if you ever are doing a problem where you need to figure out which of the products are solid, you can look at these rules. Okay? All right. So that finishes up basically talking about our displacement reactions. So now I want to say a little bit about that 5th category, our combustion reactions. Okay, so combustion reactions are anytime a hydrocarbon reacts with oxygen gas. All right, and this is basically burning, right? If you have a wood fireplace and you have wood logs that are burning, that's combustion. If you have a water heater that runs off of natural gas, the natural gas is a combustion reaction. All right, so in order to burn something, you need 3 things, and this is shown in this triangle here, right? You need a fuel, which is our hydrocarbon. You need oxygen, right? You've all probably done that experiment maybe in middle school where you had a candle that was burning in a jar, and if you put the lid on the jar, you deprive it of oxygen and the candle goes out. So you need oxygen source, and then you need a spark or something to start the reaction. Okay? All right, so combustion reactions, these are actually probably the easiest ones to identify. So in general, you have, here's our hydrocarbon. So hydro, hydrogen, and carbon. So these are compounds that are made up of various amounts of carbon and hydrogen. Then you add oxygen, and you always get carbon dioxide and water. These are always the products of combustion reactions. Okay, so the products are always carbon dioxide and water, though you sometimes do get incomplete burning, so I'm not going to make you figure out what those products would be, but that's why you may have a carbon monoxide detector in your house, because if you have natural gas as a heat source, if something happens to the pilot light or it doesn't quite function effectively, you may get carbon monoxide in your house, and you want to be alerted to that because it can be dangerous. All right, so combustion is used to heat homes. It's what makes our cars go, right? We're combusting the gas or the octane. So remember, oct is 8, so octane is actually C8H18. All right, so here are some examples. Let's look at how this works. So the first one, we have C5H12 plus oxygen yields CO2 plus H2O. So we can immediately identify that as combustion because we have a hydrocarbon plus an oxygen yields CO2 plus water. Okay, and if we want to balance it, these are a little tougher to balance. You have to kind of, this is a puzzle. So we start out, we know we have 5 carbons, so let's put a 5 here. But that gives us 10, 11 oxygen, and we've got 2 hydrogen over here and 12 over here. So let's put a 6 here. That at least gets our hydrogens to 12 rather. And then we have 10 oxygen plus 6. We have 16. And it just turns out that if we put an 8 there, we can balance out that equation. Okay? All right, so why don't you try this, and I'll give you the answer in a minute. Here's your equation. So here's your hydrocarbon, C10H22 plus O2. So I want you to write out the products, okay? and then see if you can balance it. This one's a tricky one, so pause it and give yourself time to balance it. All right, how did you do? So I said this was a tricky one. You should have gotten 2C10H22 plus 31O2 yields 20 CO2 plus 22 H2O. If you figured that one out, then you are good with your balancing. And if you didn't, don't worry. As I said, this is one of the tougher ones. But it just takes a little bit of playing with the puzzle to make the pieces fit. Okay, so here are some combustion questions. So this is part 2 of your homework. So I want you to go through and answer 1 and 2, and then do the same with these 2 equations, A and B. So again, pause the video so you can write down the questions and add those to your homework. All right, and I've got one more piece of the puzzle. Now that we've finished all 5 of the reactions that we're going to do, here's 5 reactions below. I want you to state the type, predict the products, and then balance the equations. If you can do this, then you have mastered the material in Chapter 11. Okay, I hope some of that's helped. I know you still may have questions. Turn in your homework. And then on Wednesday, or the next time I see you, we are going to